the concept of this video is about inequalities and specifically solving multi-step inequalities. And so just a few reminders. When you multiply or divide by a negative, remember you need to flip your sign. So remember, if it's pointing towards the right, it's now going to point at the left. Just make sure that you kind of reverse that around. I do think it's one of the things that can go unnoticed in terms of your steps in solving. Also remember that we're graphing these solutions, and we should make note of what type of graph. So these inequalities are only going to have one variable. Okay, so most often an x value and that you're finding. So we no longer have two variables, we just have one. And when you just have one x value, you're just going to be graphing on one x-axis, okay? So you want to be careful that you don't get confused with maybe like a linear inequality where there's an x and a y, and you would rather be plotting on, a coordinate plane. So you would do this type of graph, let's say a dotted line with some shading, when you've got an inequality that may look like 2x plus 4 is greater than y, let's say. So here you've got an x and a y value. But in the above state, where you've just got a number line, you're going to see something less like the one below, where you've got only one x value as your only variable. You don't have a double variable case. So again, two variables lead to two axes. One variable leads to just one axis, okay? So let's go through and look at two special types of inequalities that you would maybe see in your movement through this these type of questions. So you would solve this just like normal. The only step that you'd have to be careful for is if you multiply or divide by a negative. But other than that, everything is the exact same. So you would distribute first, and then look to move x's to one side and numbers to the other. So what happens is your variable cancels. So you may stop at some point where it looks like this, where you've got negative 32 is less than negative 34. Well, this is not a true statement. This is actually a false statement, because negative 32 is actually bigger than negative 34. So when you get a false inequality here, this leads you to the solution no solution, which means there is no value of x that I can plug into this inequality up here. There's no value that I can plug in here and here that will ever make this inequality true. Every number that exists would make this false. So therefore there are no answers. Okay. In the second question here, you've got a negative 1 that you distribute. So you're left with 6 plus 7x minus 8 is less than or equal to negative 2 plus 7x. Again, I'm going to combine like terms first here. So 7x minus 2 is less than or equal to negative 2 plus 7x. And when I look to get the x's together, they cancel, leaving me with negative 2 is less than or equal to negative 2. Well, because there's an equal to sign here, this makes this inequality true. Because they are equal. They don't always have to be less than, it could just be equal. So because this is true, this leads to the solution infinite solutions, which remember means that any number that you plug in for x, so any x value that you plug in here and here, no matter what that x value is, this will always be true. And it's because of the idea that when the x's are gone, you've got two values that are just going to constantly be the same thing. So that would provide the equal to. So infinite solution means any number, and no solution means there's not one number out there that would make this work. Let's look at two other examples just to make sure that you've got a full understanding. I would encourage you maybe to push pause, maybe try one of these on your own. We're going to do two examples here. So in this first one, I'm going to go ahead and distribute to both parentheses here. So negative 34 greater than or equal to negative 1 minus 5x plus 3x and minus 27. So when we combine like terms, we're left with negative 34 greater than or equal to negative 2x minus 28. Solve from there. So here's a great example of that dividing by a negative, this step right here. So I am dividing this equation by a negative, and because of that, I'm going to have a reverse sign. So first, I'm going to do this on the left and get 3. My sign is going to be reversed, so instead of pointing at the x, it's going to point at the number, and then I've got x. The problem with this is that it does become hard to understand or even graph in terms of when x is on the right-hand side. So I'm going to reverse the order here. So I'm going to put x first and 3 last. And then I'm going to just make sure, see how this is pointing at the 3 here, right? So I'm just going to make sure that my inequality sign that I write is pointing at the 3. So there's my final inequality. To show visually these answers, I'm going to find the 3 on the number line. This corresponds to a closed dot because of the fact that 3 counts as an answer. So closed dot here, and then this is greater than, so in this direction is where it's greater than 3. So here is my answer right here, visually and algebraically. So here's my visual answer, here's my algebraic answer. Okay, let's look at one more. So if we were to solve this one, we could combine like terms on the left and distribute on the right. Again, dividing by a negative. So because of that, this is going to be n is greater than 16. So when we go to graph, here's 16. Because there's not an equal to sign, that means 16 does not count. So I'm going to have 16 there with an arrow going towards the larger numbers. All right. I should go back now that we've talked about graphing a little bit. How do you actually graph one of these special cases? For infinite solution, you would have a number line. So let's say here's your number line. To graph on this number line, you essentially create a graph with an arrow going in both directions, which means that all numbers are solutions here. For the opposite, for no solution, you have a number line, right? You just don't graph because none of these numbers on this number line is a solution, whereas in this case, infinite solutions means that all numbers are solutions. So that's why there's an arrow going over everything here and nothing on this graph saying that there are no solutions. As always, if you have any questions, please come see me, and I encourage you to go back through and rewatch any of this if you are also still confused.